Hello, I'm Dani. Welcome to the workshop. Today we're talking about segment 1 of Certified SolidWorks Professional exam. I passed this exam for 58 minutes with maximum score, so if you know what you're doing, you won't have any trouble to take the exam. If you have any questions, ask them in the comments. Stay with the video to see what you have to know about this part of the exam. Certified SolidWorks Professional exam is divided on 3 different segments. In these different segments, you should show knowledge in different areas of basic SolidWorks features, but your knowledge should be advanced, so you should be really familiar with all the base features and to use them properly. The exam itself for segment 1 is 70 minutes, minimum pass score is 75 points, maximum 105 points. In this segment, you should look on creating a part from a drawing, using link dimensions and equations to item modeling, using equations to relate dimensions, updating parameters and dimension sizes, mass property analysis, modifying geometry on initial part to create a more complex part, modifying parameters on the part at different stages while maintaining all other dimensions and design intent. This as a text could be a little bit confusing, but in short, this means you should be able to use global variables and equations. You should be able to use the base features. You should be able to create the model that you're asked for in a smart way, so you should understand the drawings really well. Now, for this tutorial for segment 1, I had made a poll in LinkedIn and you have chosen to make a watch part. I have created this PDF, link for it will be available in the description of the video so you can download it and try it by yourself. So, what we see now is on one place I have all the information that you will have during the exam with a different part, of course, because the idea is you're confident in any situation you can have in your exam. What we see here are our variables. Some are set with a number, some are calculated. This means that your first step, the very first step, will be to create your global variables inside your file. So this is my part. So usually you go here from Tools, Equations, and start adding your global variables. A is 46. B is A plus 14. C is 22. D is 12. E is A minus 4. F is C plus 2. Sorry. G is A plus 4. And the last one, H, is A plus 2. Now, if you're wondering why is this needed, why you need this knowledge, when you're creating a part which will be family, like for example a bolt, or it could be connector, usually you have some sizes that are changing, other relations which are sitting the same. And in your work, if you're working in such company that have big family of files, it's much easier and better to use global variables for this definition so you can create or ease your work. So once we are ready with our global variables, we should have a look on our drawing and have an understanding what is coming first, what we should build first, keep in mind that you should be fast. So you really have to be confident with understanding the drawings. While looking on this drawing, what I can see for sure that the base part is revolved. We can see it from here. We have also the sizes of the outer revolved part. We have here the center line. We have also the 3D. It's pretty clear that base part is revolved, that has some cutouts. When looking on this drawing here, I can see that this is a straight cutout. It's easy, we can use the standard cut, but the cutout here, it's a bit more complex. There are two ways to do it. You can do it with loft cut or you can do it with swept cut. I will do it for this tutorial with swept cut. But first we start building our base part, which is with this outer contour here, revolved around here. And then we go further. So the outer shape is ready. We have here bottom a radius 1 and here we have also radius 1. In this case we can use also link dimensions. Linked dimensions are very comfortable when you have same size on many different places. You can link more than 2 dimensions. You can link 5, 10, as much as you need. All you have to do is click on one of your dimensions that you want linked, then with control click collect all the ones that you want, then right click and link values. Name this dimension. I will just name it name it in a way you will recognize it. But for this tutorial, I don't need a very good definition. Then what we can see that the internal diameter is equal to our value E. This is where it's really, really comfortable using predefined global variables. Then what I see next, R5 is the inner radius, R10 is the outer. The other important thing is that the distance from the bottom to the center of this radius here is 4. This is always 7. The total height is equal to D. Now I will have a brief look where I'm missing definitions. Okay, so I missed this point here, the diameter on which it goes, and also the outer diameter. When I look here, the outer diameter is B. Okay, something is happening here which I don't like. We said here it's E. Yes. And the most outer diameter is B. Okay, here is not tangent. And now we're missing also this definition here. When we have a look on our model, we will see that this is E. We're looking for the outer edge. Okay, the outer edge is A. Now our shape is ready, it's fully defined. We can make our first base model, which is revolve around this. Now, we have 2 cuts to do, or actually 3 cuts, because here we have also the pin cut. As we can see, this is related to the inner cut. So we should start with this cut here. As we can see, it's angled, and we have also sizes. We have H and G. First, I will make a path for this cut on the top plane. This part should be with diameter H. And then we need also to cut it out. And the distance is C. And we exit and we go to the right plane, where we will draw our cut profile. As I said, it's angled. Here we have to measure again diameter, so we need a center line. This is coincident. Okay, I made a wrong relation. Maybe I will go with collinear. So the top one is H. And the bottom one is G. Now, to have it fully defined, I will recommend you to adjust some distance here to keep it on enough distance so you have clean cut, not leftover pieces. Once we are ready, we can make our swept cut. I take the profile, I take the path, make it in the middle. Normally, when you do swept cut, you will have it, the profile will follow the path. You have to go to options and keep normal constant, so it's ending straight, so parallel to your original sketch. Then what I will do next is just to mirror this cut on the other side, and this cut is ready. Now I can choose either I made this cutout first or the side cutout first. It really doesn't matter. I will make the side cutout. I'm sorry for the noises, but it's in my neighbors decide to do something. Now I will add again a construction line to mirror my cutout. So here it's very important to see exactly the most outer contour and to grab this one. Because of the radius, we have two lines here, and you should be careful when you're designing also the part, when you're doing the part for the exam, be careful because such small thing can ruin your exam. So it's going to here on both sides, and then we have a radius 5. Just to be sure it's on the correct position, you can just make the line longer and use the trim tool. We have to convert this line too. So what we know from the drawing, this is on distance 3 from this cut here. We don't have to measure it for both sides. We can do that, of course, and use again link dimension, but in this case they're vertical. We can do this also for here. And then we have 30 in between. So, and yeah, radius 5, we will use fillet. Actually, fillet, when you use it in the sketch, is automatically creating this radius is equal, but you can do them also individually, and with linked values, it's harder to do it that way. I will make this a construction line, and we'll add a little bit bigger area to be cut out, just to be sure that we cut everything we need. Give it some distance from the outer edge, just to define it, because if we're going to change this part in a very big one, we want to be sure that it's far enough. If we leave it not defined, it's possible that it overlaps here. Again, mirror. And we cut blind in this direction through all. Okay, and there is one more cut left that we have to do. We are going back to the sketch. Here you will see that we have a hole with a diameter 1.2, 1 millimeter from the bottom, 1.2 from the side. We are going again in the right plane. We can use a section view here so we can see better. We make these two equal. Diameter 1.2. Distance from the side 1.2. Here is a good place to use the linked values. In this direction, you don't need a second measurement. You can just make the two center horizontal. I'm exiting the sketch and I'm going again to the normal view. What I can see here, this is also a global variable value, which is f. We make extrude cut, mid plane, and the value of f. So this first part is ready. And now we can check if we apply this material brass, if we will have this value of the mass 28.48. So we go to materials, edit materials. I'm already on brass. If you're wondering, it's under copper alloys. I applied. Then we go to evaluate mass properties, 28.48 grams. Exactly. So we build the part correctly. Next step or next few steps of this exam will be to modify this part in a different ways. I will not do all the steps for the exam. I will just give you example with one more modification of this part. It's on the bottom side of the PDF. Now here you can see I don't have any more the other dimensions. They're staying the same. The variable dimensions, they're staying the same variables. So what I have here as added information is for the changes that we have. First, of course, we have to go through all the values that we have here to check if they're correct. In my case, the calculated are staying the same, but in the exam there could be changes also here. So pay attention to each global variable. So here we have A42. B is the same, C is 20. D is 10. E is the same, F stays also the same, G and H2. Now you can see that when I go to equations, we can see also where we are using the global variables. Once I'm ready, I hit OK. Just in case, you can hit also rebuild and your part will rebuild. For some changes, you should use also rollback in your tree. For this particular case, I will not need anything else. So what we have is the changes here. We have here additional boss extrude that we can see. And then we have these two cuts. First, I will make the boss extrude. I will start from this face now. So we have this line, then we have another with radius 23. I will use center point arc. We say it's 23. These two, again, they're going vertical. The distance is 10. Then we have 2 times radius 5, which is tangent to here. Okay, I will move it a little bit so I can move the point later. So we have it tangent to here and coincident here, and the same here. I think they were too far away. Let's hope it's proper. I will make this again. So these two are equal. We can just make them equal, and there are 5. And it's going up to the bottom side here. We have it blind, actually up to surface. What we see here is also we have a radius, but it's not dimensioned. When you look here, you will see that it's actually rounded up to the edge. Which means that, yeah, we can calculate the value based on our outer diameter and the inner. It's 2. Now, the next one, it's a bit more complicated. We have to create a reference plane on which we will place a drawing and make this cut here. As we can see, we need a line on 32 degrees. We are going on the top plane. Make a line coincident to here. I will make another line to here. 32 degrees. And I will exit this sketch and create a reference plane with this line and this point. On this reference plane, I can make a new sketch. And on this new sketch, I will add my cutout 8×4 with R1. You can see it's equal from top and bottom, and it's in the middle here. Now we can make extrude cut up to next. We can hide the sketch and we can mirror it. Now our second modification is also ready. What we will have to do is again to check the mass. Check if the material is the same. 25.06 should be our mass. And it's that much. So more or less the professional exam will continue this way. You will have approximately 4 modifications of your part. Build your part smart, be fast, be confident, and you will have no troubles to take this segment 1. Now you have an idea what is expected for the Certified SolidWorks Professional Exam Segment 1. There is also a sample exam available. You can take this sample exam to have a better feeling of the exam itself. Don't forget to like this video, subscribe for the channel, and see you next time. Bye!